So this video is for, this is Specimen Paper 2, number 6. And we went through, one of the classes we went through a lot of this in class, so you can skip ahead in the video if you just want the last steps that we didn't get to, but I'll go through the whole thing again here. So for part A, to get the transition matrix, we want to set this up from to, and then we've got company X and Y like this. Okay, and then it says 20% of the customers using company X move to company Y. So that's from X to Y is 0.2, 20%. And then 10% of the customers using Y move to company X. So that goes here. And then we do 1 minus 0.2 is 0.8 and 1 minus 0.1 is 0.9. So that's our T matrix for part A. To find the eigenvalues, we do 0.8 minus lambda times 0.9 minus lambda, so the diagonal values, and then subtracting the product of the other diagonals. So 0.2 times 0.1 is 0.02. We set that equal to 0. We solve for lambda. We have to multiply all this out, so 0.72. Okay, and then we do minus 0.8 lambda, minus 0.9 lambda, so that's minus 1.7 lambda. Then negative lambda times negative lambda is positive lambda squared, minus 0.02. Okay, combine like terms, and let's put it into standard form. Okay, and then 0.72 minus 0.02 is plus 0.70, or just 0.7. And then we want to use the polynomial root finder to find lambda 1 and lambda 2, or you can graph this quadratic and just find the x-intercepts. And so you shouldn't be doing that using the quadratic formula, or, I mean, you could, but it's going to take longer. And please make lambda 1 the bigger value, just for consistency. This is the primary eigenvector, or eigenvalue, and this is the secondary eigenvalue, so that should be the smaller number. That's how they're going to want you to do it on the final exams. The examiner is going to expect the bigger value to be lambda 1, the smaller value to be lambda 2. So the next step is to find the eigenvectors. And so first thing we have to do is plug in. This matrix should really be 0.8 minus lambda, and then 0.1, and then 0.2, and then 0.9 minus lambda on the diagonals. So we need to plug in this 1 in for lambda first. So for lambda 1 equals 1, we would get a new matrix. 0.8 minus 1 is negative 0.2, and then we just copy down the other diagonal. And then we do 0.9 minus 1, which is negative 0.1. Okay, then we multiply this by x and y and set it equal to 0. And you just need to do one of the equations. So negative 0.2 times x plus 0.1 times y equals 0. And solve this equation for y. First thing I would do, we don't want decimals in our eigenvectors, so multiply everything by 10. So you get negative 2x plus 1y. The reason I multiplied by 10 is to get rid of, these are tenths place decimals, so I multiply by 10. And then solve for y, so we just add 2x to both sides. And now to get the eigenvector, you just make x equal to 1 and see what y is when you plug it in. So y equals 2 times 1 is 2. And this is the smallest multiple answer. This is the one they're going to expect you to find. You could, the same thing could be 2, 4 or 3, 6, but we don't want those. We want the smallest multiple. Okay, for lambda 2 equals 0.7, we need to first plug it in and get that matrix. So 0.8 minus 0.7 is 0.1. Then we've got 0.1, 0.2, and 0.9 minus 0.7 is 0.2. Can we do the same process? 0.1x plus 0.1y equals 0. Multiply by 10. Solve for y. We get y equals negative x. Now when we find the eigenvector, we want to, again, make make x1 first, and then that would mean y would be -1. And so these are the eigenvectors, 1, 2, and 1, 1, 1, -1. Okay, the next step, part C, hence write down matrices P and D so that we write this equation. So all you really have to do is tell me what P and D and P inverse are. This is only 2 points. So P, it tells you this in the formula booklet. P is the matrix of eigenvectors. And so the order here matters. P, let me write it up. Oops. P is, so we do it's going to be a 2 by 2 matrix. We do the first eigenvector first, because that corresponds to lambda 1. Then we do the second one in the second spot. So that's P. D tells you this in the formula booklet as well. It's the diagonal matrix of eigenvalues. So 1 goes on in there, and 0.7 goes on the other diagonal, and then these diagonals must be zeros always. So that's how you write D. And then P inverse you just do on your calculator. Type in matrix P into your calculator, and then type P to the -1. There's a button on your calculator that looks like X to the -1. So you just call up your matrix P and do the inverse on the calculator, and it's going to give you decimals. This one's going to say 1/3, 1/3, 2/3, -1/3. It's actually going to be 0.33333. What you should do is use the math button and change this to fractions so that you can see P inverse is actually going to be easier to write if we pull that 1/3 out and then we just copy down the coefficients like this. That's really how we want our P inverse to be. So P, D, and P inverse, you just have to write those down somewhere for 2 points, and I'll find those. Okay. So then going on to the next part, I'm going to have to erase some stuff for part D and E. So actually, I think I'll just make another video just for that part.